All right, hello everyone. Welcome again to another one of Mr. Martin's math videos. This is for Math 9, according to the Canada's BC, British Columbia province math curriculum. We're looking at Chapter 5, which is all about linear relations, and Section 1, which talks about representing patterns. So by the end of this lesson, we should be able to represent pictorial, oral, and written patterns with equations, identify fixed and variable values, and also solve problems that involve these pictorial, oral, and written patterns using equations. So, for the last two chapters, we've been looking at some of the keywords in algebra and how to work with the strange, wonderful world of polynomials, right? You just wrote a test on that. These next three chapters, I think actually the next two chapters, will take you through the exciting world of algebra. Yes, we'll finally have a chance to use algebra for what it was intended for, modeling and solving problems. Okay, a big part of what's so awesome about algebra. So to start off with, let's take a look at one of the most impressive, I'm going to make this a little smaller here, one of the most impressive feats of human engineering, the super tanker. All right, really impressive vessel here. Okay, and you can imagine, these large vessels, they're quite cumbersome to navigate. Captains of these ships definitely have to think in advance the types of maneuvers they're going to do before they actually are able to execute those maneuvers. All right, so let's take a look here. This is a table that is representing two variables that are being measured for this ship, right? So this table is referring to a boat, all right? It's telling us with time is being changed and it's being recorded every 3 minutes, okay? And you can see that every time time is recorded, they're also recording the speed of the boat. And so as time is increasing, notice that the speed here is going from 30 to 24. So what is the motion? Describe the motion of the super tanker. And what is happening for the motion of this super tanker? All right, so here, hopefully you're able to see that the super tanker is slowing down, right? Its speed initially was more than its speed after 15 minutes. Okay, but it took 15 minutes to reduce speed. Okay, so that's what's happening in terms of the motion here. So let's look at some of the questions based on this problem here. So what do you think the speed will be at 4 minutes and 5 minutes? Okay, all right, so here we know that for every 3 minutes, we don't have data for every minute, but we know that for every 3 minutes, the speed of the boat changes or goes down by 6 kilometers an hour, so minus 6 kilometers an hour. Okay, so if every 3 minutes, and again, 3 minutes here, it goes down by another 6, and so on and so forth. So if every 3 minutes the boat reduces its speed and time here, right? Here we want to figure out how much speed it reduces for every 1 minute. So we know that it's negative 6 kilometers per hour every 3 minutes. Okay. So how can we determine how much speed it reduces every 1 minute? Okay, well, you just have to simplify your fraction. So if I have negative 6 over 3, that is equivalent to negative 2 kilometers per hour every minute, every 1 minute. Okay, so every 1 minute, the boat is slowing down by 2 kilometers an hour. So that means for the fourth minute, at the fourth minute, if at the third minute it's traveling at 24 kilometers an hour, after 1 more minute, the speed will have gone down by another 2 kilometers based on what we saw here. So the speed at 4 minutes should be 22 kilometers per hour. Okay, and after 5 minutes, the speed would be 20 kilometers per hour because you have another minute that's gone by, so another 2 kilometers of speed has been reduced in that minute. All right, what patterns do you see in the table from one row to the next? All right, well, we showed 2 patterns here. Time increases by 3 minutes every row, right? And speed, what did we say? Speed decreases by 6 kilometers per hour. Okay, so for every 3 minutes, you have a decrease in speed of 6 kilometers an hour. An equation to model this tanker that they've come up with is this equation here. S is equal to negative 2t plus 30. What do the negative 2 and the 30 have to do with the data on the table? What is the negative 2 and the 30? Where did we see negative 2 and where did we see 30? All right, well, we see negative 2 over here, right? We see negative 2 over here when we came up with the rate at which the boat was slowing down per minute. Okay, so the negative 2 is the rate of change for the boat speed. Okay? And where's the 30? Where does the 30 come from? Well, 30 comes from right here, the very first value. My meandering line. So 30 is that initial value. Okay, and here we're kind of introduced to 2 really important terms when it comes to linear relations. We have our rate of change and initial value. And these 2 values, they show up in our equations that we're going to be making for linear relations. All right, we're always going to have a rate of change and an initial value that we have to put in our equation. Okay, what do you think the S stands for in this equation? Hopefully you're able to determine that S stands for the speed of the boat. And if that's the case, then what do you think T stands for? Yes, T stands for time. All right, so you multiply the time by the rate of change of the speed. And so if it's 5 minutes, you multiply 5 times negative 2, and that gives you negative 10 kilometers per hour. And then plus 30, which was the initial speed, gives you 20, which is what we solved for here. Okay, so we see that the equation works. We can try another point if you like. Let's say 4 minutes. 4 as time, so I would place it into the t value here. So 4 times negative 2 is negative 8, plus the initial value of 30 kilometers per hour gives me a final speed of 22 kilometers per hour, which is what we determined as well earlier. Okay, so you see how these values kind of interact. All right, and we'll introduce these more and more as we go. All right, so let's look at another pattern here. We started with the first pattern, which was this boat traveling in the water, slowing down, coming to a stop. Let's try these shapes here. Now we have a bunch of figures here, figure 1, figure 2, figure 3, figure 4. And you'll notice that blocks or squares are being added to each figure, okay? So what would you describe to be the pattern of the blocks being added from one figure to the next? All right, so hopefully you were able to see that every figure, one to the next, is adding 3 more blocks to the previous one. Right? Plus 3, plus 3, plus 3 blocks. Okay, adding 3 more blocks to next figure. Okay, just kind of a sentence description. All right, so let's create a table of values that represents the linear relation between the number of squares and the figure number for the first 4 figures. Okay, now wait, what is a linear relation? All right, well, our textbook tells us, does it describe it in the textbook? In 5.2, but I'll put is a linear relation is when a straight line is graphed and it has a constant rate of change. A relation with a constant rate of change. All right, so that's what we're going to be using as our definition. Okay, what should we put on the left and the right? Okay, let's introduce our values here. Okay, split it in half. On the left side, I'm going to put figure number. All right, and on the right side, I'm going to put number of blocks. You got it. All right, number of blocks. All right, and now here I have 4 figures. I'm going to leave a space, okay, because and you'll see why in the future here. But I'm going to start with my first figure on the second line. I'm going to leave a blank space here, okay? And that'll be a good trick for you guys when you're dealing with these specific types of questions that have a figure. You'll want to kind of skip a line here, okay? Because you want to leave room for figure 0, even though figure 0 doesn't exist. But we'll talk about that in a second. So 2, 3, and figure 4 down here. All right, how many blocks does the first one have? Well, first figure has 1 block. Second figure has 4 blocks. Third figure has 7 blocks. And fourth figure has 10 blocks. All right, awesome, good. So here, if you kind of track on the left side here, we can see that the figure number is increasing by what each time? It's increasing by 1. You guys see that, right? From 1 to 2, from 2 to 3, from 3 to 4. How is the number of blocks increasing from one figure to the next? Well, each figure, we're adding 3 more blocks. Okay? And because here both sides are going up by a constant amount, all right, that means that we're going to have a constant rate of change. Okay? And our rate of change here is going to be 3. Okay, and we'll talk about that in a second. But, so let's see if we can write a linear equation to represent this pattern. The equation should use the number on the left side to somehow get the numbers on the right side. So how can we come up with an equation here? All right, well, let's follow the steps on how to write a linear equation using a table. All right, so first, the format of the equation, this will become a very important equation for you guys, is y equals mx plus b. You'll be using this equation even when you're in grade 11 and grade 12 and afterwards. Okay, it's an equation of a straight line, extremely important. All right, and now it has a bunch of parts that we're going to describe here first. Okay, so the letters may look a little strange, but you'll learn more about them in grade 10 and also in the future. But there are some important concepts that we can point out. First, let's start with the y. All right, y represents the dependent variables. Okay, in this case, the dependent variable is the responding variable, or the one that's changing because of the other variable. Okay, so in this situation, the dependent variable is the number of blocks. Okay, because the number of blocks change because of the figure number, okay? It's not the figure number that change because of the number of blocks. The number of blocks is determined by the figure number. It's not the figure number determined by the number of blocks, okay? So that's what the kind you have to ask yourself this to determine the dependent and independent variable, okay? And you know these words, right? Independent. What does it mean to be independent, right? Is that nothing around you affects you, okay? Well, not quite, but that's what it's independent of influence, right? Whereas dependent means that you are influenced and impacted and controlled by an external, body. Okay, so independent in this case would be the figure numbers. Okay, and as the figure numbers change, that's when the blocks are added. Okay, we don't add a figure number because of the number of blocks. We add number of blocks based on the figure number. Okay, one is the responding variable. The other one is more the predictive variable. All right, so that's our x and our y. We've covered those. Now let's talk about our m. Our m represents the rate of change. We talked about this word earlier when we looked at the both, rate of change. How does the dependent variable change? So at what rate does the dependent variable change? Okay. All right, so that's the rate of change. The other one is the initial value, and that's our B. Initial value. Okay. And so this is, for initial value, we kind of typically represent this as what is it's a starting amount. So in our boat example, the starting amount was 30 kilometers. That was the initial speed. Okay. So starting amount, and this is specifically, it's the starting amount. Sorry, not amount, when x is equal to 0. Okay, so it's the amount when x is equal to 0. So, and I, was intentional here about making this point because in this figure here, okay, our starting amount, what would be our starting amount here if that was our only definition? The starting amount would be 1, right? However, that's not right because in this situation, here we're starting at 1 when we need to start at 0. Okay, so that's why I left that space here. Okay, the initial amount of blocks is not when the figure number is equal to 1, it's when the figure number is equal to 0. So if I were to write 0 here, which is 1 less than 1, how many blocks would I have at figure number 0? And this is now, you have to think theoretically and not concretely, okay? Obviously, I can't have less than 1 or 0, less than 0 blocks. But mathematically, I can conceptualize -2 blocks, right? Because I know that it should have 3 less than the previous one. So here, my initial value for this situation would have to be -2 when it's at figure 0, okay? Which again, it's theoretical, it's not concrete, right? And so you have to kind of be able to see these numbers in your equations. All right, so in this example, we're going to focus on finding the rate of change m in this problem that we've been tackling here. All right, so to do this, all we need to know is how much the pattern is going up or down for each figure number. So in the table above, the rate of change would be what? For each figure number, the number of blocks goes up by 3, right? And so our rate of change here, which is equal to this would be equal to 3, okay? +3 specifically. since it is going up by 3 each time. All right, so far in our equation, if our basic equation is y is equal to mx plus b, now the x and the y, you're not looking to change those. Those are there in the equation so that we can measure things as our situation changes, okay? But that equation will be able to measure at different points. Like it was able to measure the boat's speed after 3 minutes or after 6 minutes or after 5 minutes even in our initial question. So the x and y, they're going to stay x and y in our equation. But what we're trying to do is to solve for the specific values in this problem for the m and the b, okay? Just like here in the equation that we looked at before, notice that the s and the t, that's our x and that's our y and x, okay? They stay in the equation. We change everything else, okay? We change that. We want to find the m and the b. So I know my rate of change is 3, so I'm going to substitute that into my equation. Y is equal to 3x plus b. Okay? Now, all I have to do is solve for b. Now we just need to figure out how much to go up or down to get the number on the right side of the table. Okay? So what is b? What is our b value? Our b value is that initial value, and specifically when x is equal to 0. Let me write that differently. Bracket when x is equal to 0. Okay? So b value in this situation, because we left that space in our table, we were then able to come up with a mathematical initial value when the figure number is 0. Theoretically and mathematically, the original initial amount of blocks that we would have then would be -2. Okay, because we have to stay with the same rate of change on the left side. So -2 plus 3 would be the 1, and then plus 3 would be the 4, and so on and so forth. So you go -3 to work up the table, plus 3 to work down the table. So my b value would be -2. So now I have my full equation. Y is equal to, I said that 3x minus 2. This is my equation for the problem we were looking at with the blocks. So now we can use this equation to solve for other figure numbers or other numbers of blocks. Okay, that's the beauty of having these equations. So let's try it out. How many squares are in figure 12? Okay. Do we need to draw up to figure 12 to find out how many blocks there's going to be at the 12th figure? Well, no, hopefully not, right? Because that would be a lot of drawing. So what we're going to do is we're going to use our equation. We have a figure number, and we said that is equal to x. And in this situation, our figure number is equal to 12. All right? And we want to know how many blocks. Well, number of blocks is equal to our y variable, and we can solve for that by plugging in our equation. So I have my equation here. Y is equal to 3x minus 2. And now I'm going to plug in, instead of x, I'm going to plug in 12 in the place of x. Now when you're substituting in equations, you always want to use brackets, okay? And then I write minus 2. Okay, so now instead of x, I substituted x for what x was equal to in this problem, which is 12. All right, and now I just do the math. Y is equal to 36 minus 2. Y is equal to 34 blocks. Okay, so I was able to solve the number of blocks that would be in the 12th diagram without drawing the 5th, 6th, 7th, 8th, 9th, 10th, 11th, and 12th figure all on a piece of paper. I was able to use my equation to solve for the amount of blocks. Okay, now we can also flip that around. We can use the number of blocks to solve for the figure number. So here they give us a figure number of 106 squares. So again, they want me to solve for x, but now they're giving me y, right? We know that y is equal to number of blocks or squares, I guess they're using, which is equal to 106. Okay? Now I can safely say that it's going to be more than 12, just because 34 blocks was this 12th figure. So let's see if we can figure this out. So we're going to substitute. Again, we're going to start with our equation. Y is equal to 3x minus 2. I'm going to substitute y for what I know y to be equal to. So 106 is equal to 3x minus 2. All right. Now here I'm going to use some algebra. So in algebra, in order to solve for this equation, I need to solve for x, right? That's what I'm looking for here. All right. And here I substituted y for what y was equal to. All right. So here in algebra, to isolate the x, I need to get it by itself. So I move the minus 2 to the other side of the equation by adding 2 to both sides. Okay, in algebra, whatever you do to one side, you have to do to the other side. And you have to do I want to make that negative 2 equal to 0, so I add 2 to it. And as long as I do it to both sides of the equation, I'm allowed to. Okay, so this cancels out, and I end up with 108 is equal to 3x. All right, and last algebraic step, to get x by itself, because it's 3 times x, I'm going to divide both sides by 3. 108 divided by 3, and that's going to give me x is equal to 36. Okay, so here this is saying that figure 36 will have 106 squares. I was able to use my equation again to solve for a figure without drawing 36 different figures and then counting the blocks by hand, which would be tedious and long and would take me the rest of the day. Maybe not the rest of the day, but it would, more of my day than I would like. Okay, let's try another one. That's a lot of new stuff there, and so let's try another one. And again, if you need to stop, rewatch some parts of the video, or you're doing your homework and you watched this video initially and now you forgot some stuff, just rewatch it. You know, like this is a resource for you that's saved and accessible whenever you need it. Let's try another one. This one is another figure kind of situation, geometric kind of situation here. From figure 1 to figure 2, I'm adding 2 blocks, and then 2 more blocks each figure, right? So here it's just plus 2, plus 2, plus 2. So pretty similar to what we had here. This was plus 3, plus 3, plus 3. Here we're just plus 2, plus 2, plus 2. So again, we're going to make a table for the relation. On the left side, you always want to put the independent variable. And on the right side is the dependent variable. Okay, so independent variable, again, here is figure number. Oops. On the right side is number of, in this case, is circles. All right, so this is my table here. I have 4 figures again, but again, I'm going to leave an empty space. All right, I'm going to start 1, 2, 3, 4. And so in figure 1, I have 1 circle. Figure 2, I have 3 circles. Figure 3, I have 5 circles. Figure 4, I have 7 circles. Okay, so again, here you see that as the figure numbers increase by 1, the number of circles increases by 2. Okay, this also shows us that this is in fact a linear equation, which means that if we were to graph this, we would get a straight line. Well, we'll talk about that in the future. Now here right away, I can try to solve for my my rate of change in my initial value. Okay, my rate of change here would be what? As the figure number increases, how much do the number of circles increase? They increase by 2 for every change of 1, right? So my rate of change here would be equal to 2. All right, and then initial value. Now this one, again, this is why we left the space here. My initial value has to be when the number of figures is equal to 0. And when is the, so it's a theoretical figure number, okay? So how many circles would there be if my figure number was 0? Well, because I know that the number of circles increases by 2 each time, if I subtract 2, I'd get my initial value, which is -1. Okay, so -1. And I know that my rate of change is m, and my initial value is b. So now I can create my equation, which is what they want us to do here. So equation, the format is y is equal to mx plus b. So I know that my m is equal to 2x, and my b is equal to -1. And that's my equation that I'm going to use now to solve for these other situations here. All right, so let's take a look at this. How many circles are in figure 71? So is figure 71, is that the y value or the x value? Figure 71. Good, figure 71 is my x value. Okay, because I know that figure numbers is my independent variable. So these are my x values, okay? Number of circles are my dependent variables. So those are my y values, okay? So here, they want to know how many circles, so what is the y when x is equal to 71? So I start with my equation, y is equal to 2x minus 1. And I'm going to substitute what I know x is equal to in the places of x. So y is equal to 2 bracket 71 minus 2. And then here 2 bracket 71 minus 1 is equal to 141. So there's going to be 141 circles in the 71st figure. And I'm so happy that I didn't have to draw those all out to find that answer. I was just able to use my equation. Okay? And then now let's again look at another problem. Here, which is the figure number with 82 circles? So in this situation, I don't know what x is. That's what I'm solving for. They tell me that the number of circles, which is my dependent variable, which is the y value, is 82 circles. Okay, so again, starting with my equation, y is equal to 2x minus 1. I substitute the value that I know. I'm going to replace y with what y is equal to. So I'm going to put 82 is equal to 2x minus 1. And then algebra, again, first I got to deal with the minus 1. I'm going to add 1 to both sides. All right, and that's going to give me, I'll work this way here. 83 is equal to 2x. And then divided by 2, divided by 2. Interesting. 83 divided by 2 gives me, so again, here mathematics doesn't always follow kind of real world situations, okay? Yeah, I would say that here in this situation, it would be the 41st.5 figure that would have 82 circles, okay, which doesn't make sense. But again, neither does -1 circle make sense, right? And so these are mathematical. There's a blend of mathematical and real life kind of that we have to kind of blend together in these situations. All right, so, well, actually in this situation, which would be you can answer the question, which would be the first figure to have 82 circles? So if you have 82 circles at 41.5, which figure would be the first one to have 82 circles? The 41st figure or the 42nd figure? Okay, the 42nd figure would be the first one to have at least 82 circles. It would have 83 circles. All right? All right. Now, I want you guys to try one on your own here based on what we talked about. I want you guys to go ahead and try this question. Okay, so pause the video. And you guys have a copy of these notes that you can be looking at, and I'll also scroll through so you can, move back and forth in the video. So on your own, try this one. It has 4 rows of these beads. Complete the table. What equations shows the pattern? Determine the equation. And then these 3 questions. How many beads are in row 4? How many beads are in row 38? And if the bead pattern continues, which row would have 92 beads? So go ahead and pause the video. All right, hopefully you were able to work your way through that. So let's take a look at some of these, or this last problem together. So first, again, we want to make a table. On the right side, I always want to put my x variables, which are my independent variables. You don't have to write this stuff. You could have just put row number, right? That's the independent variable. Row number determines the amount of beads. Okay, it's not the amount of beads that determines the row number. Okay, and then on the right side, you always want to put your y or dependent variable. Okay, and that is your number of beads. Okay, so underline that. Again, I want to leave the space. So row 1, row 2, row 3, row 4. How many beads does row 1 have? 1, 2, 3, 4, 5, 6, 7. Row 2 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Row 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And if I were to say, what would you guess to be the amount of beads in row 4, what would you say? Yeah, you would expect it to be 22, right? Because each of them are increasing by 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Exactly what we expected, 22. All right. So here, as they increase by 1, the row numbers, they're increasing by 5 beads more for each row. Okay, meaning that at row 0, how many beads would you have? Because we need that initial value to solve for our b value in our equation. So at row 0, we would have 2 beads. Okay, so let's put that in our equation. We said the rate of change, which is our b value, is equal to 5, right? Because with every additional row, you have 5 more beads. And our initial value, which is equal to, rate of change is not equal to b, my mistake. Rate of change is equal to m, which is equal to 5. Initial value, which is equal to b, that's equal to 2, okay, when x is equal to 0. So that's this row here. Gives me this here. So if I want to plug these into my equation, y is equal to mx plus b, it would give me y is equal to, in the place of m, I put 5x plus, and this would be 2. And that would be my equation. Now I can use this to solve the problems on the next page here. So I'm going to keep that in the corner there. How many beads are in row number 4? Well, we don't really need this equation to solve for this because we already know that in row number 4, we have 22 beads. Okay, so no equation here. 22 beads. Okay, make sure you put your units. Don't just put 22. It's not just 22. It's not 22 orangutans. It's not $22. It's 22 beads. Okay, you want to be specific in your units. It's not 22 meters or 22 seconds. Now, how many beads are in the 38th row? Well, I don't want to draw 38 rows, so I'm going to use my equation. Y is equal to 5x plus 2. Here they're telling me that x is equal, the number of rows is my x variables. It's my dependent variables, and that's equal to 38. And so the number of beads, what I don't know and what I need to know is my y value. So y is equal to 5, and in the place of x, I'm going to put what I know x is equal to, which is 38. 38 plus 2. So at the 38th row, I would have 5 bracket 38 plus 2. I would have 192 beads. 192 beads. Okay? And one last question here. Now they're giving us the number of beads, and they want to know which row number. Okay, so x is the unknown and y is the known, 92. So in my equation, y is equal to 5x plus 2. I substitute 92 to y because y is equal to 92, so I can substitute it in my equation, 5x plus 2. And again, now the algebra steps. Now we haven't done a lot of algebra yet, but there's just 2 steps here you have to remember. You have to get the x by itself. That's always the point. So first, it's the opposite of BEDMAS. So you start with addition, subtraction, then multiplication, division, then brackets and exponents, okay? Or exponents, then brackets. So here, I want the plus 2 to equal 0, so I'm going to subtract 2 on both sides. All right, that cancels out, and I end up with 5x is equal to 90. And then lastly, because it's 5 times x, I'm going to do the opposite. And you're always doing the opposite operation. So because it was plus 2, I subtract 2 on both sides. Okay, because it's 5 times x, I'm going to divide 5 on both sides. And that cancels the 5s, and I'm left with x. And then 90 divided by 5 is going to give me 18. Okay, so I have 92 beads at row 18. All right, if there's anything that you missed, make sure to just pause and re-watch as many times as you need. Also, reach out to me in the comments or on Teams if you have additional questions. Here's a little checkup for us. How can you, after this video, represent pictorial, oral, and written patterns with equations? Can you identify fixed and variable values? Okay. And in terms of our dependent variable and independent variable. And can you solve problems that involve pictorial, oral, and written patterns of equations? So hopefully that's some big yeses for all 3 of those. And then here's your homework assignment, 5.1, 3 to 10, 13, 14. And hand that in at the date specified in the assignment on Teams. Thank you guys all for tuning in, and we will see you next time.